Okay, it's 12:30, so let's begin here. Since about half the class isn't here right now, I thought we'd start off with a pop quiz. So please take out a piece of paper and we'll have a quiz. I'm just joking, sorry. No pop quiz. Anyway, maybe it wasn't that funny. It was funny on my end.
You'll get that a lot when she watches that.
Assignment number 6 is due November 30th at noon. For those of you who were in my Static 10 class yesterday, something that our guest speaker said made me think, well, maybe I hadn't discussed something with regards to how to use R. I just want to ask you, have I ever discussed what a workspace is in this class? I apologize if I have not. I think it's one of those things with teaching a class for the first time that some simple thing like that gets omitted. I've done introductions to R many times before, and I have included this, but I think I must have accidentally deleted it from my lecture notes because I wasn't able to find my lecture notes either. So I'm sure all of you have done a lot of stuff in R so far the last few weeks. And you've probably been wondering, well, what happens when you close out R and you have this little message that pops up? It says, save workspace image. Almost every time that I've ever used R, I have always hit no. And what that basically does is that similar to like in SAS where you have a work library or Now it's escaping me. In SAS, they are called libraries, right? Sorry, just working with 2 different softwares. Probably you've had that same experience too. It's like, okay, I need to make sure I'm using the proper term. So the work library in SAS, when you exit SAS, it automatically gets erased, all the data sets that are stored in there. Well, in R, you basically are given the choice. Do you want to erase them or not? And so when I say no, yeah, I do want to erase them. And the reason why I always pick no is because I always have a program that can be used to reproduce it. Now, if you do hit yes, then it will allow you the ability to save all the objects that are in R's database. It allows you to save it to a folder. And then, if you come back into R, you can reuse it if you wanted to. I've never had needed to save the workspace. I've had one grad student who liked to save workspaces sometimes in order to present some stuff to me. But other than that, I've never seen anybody use it. So for those of you who remember Pavel yesterday in our Set 810 class talking about workspaces, that's what Pavel was doing. And I guess he does sometimes save his workspace. So, anyway, I just wanted to bring that up. Okay, so are there any questions? We were talking about using the knitr package with LyX to get our code and output into a LyX created PDF. In other words, some people will refer to this as getting or dynamically creating a document, a report document or a paper or whatever you're writing, because the R stuff is executed at the same time as the PDF is put together. And we left off on section 5 of this, wrong document. Section 5 of this document that's based upon the serial data to introduce you to using knitr with LyX. And one of the questions that we had, I believe, last time was, well, could you reuse some code that was in a chunk? And the answer is yes. To be honest, I've never have needed to do this, but it's nice that it's available, and maybe by chance you might come across an instance where you would want to do this. So you may remember us before creating a chunk called mean SD, which basically just created found the mean sugar content by shelf, and also the mean, and also the standard deviation of the sugar content by shelf. and we put that into a chunk called mean SD. Now to reuse that chunk, just a second, sorry. Oh, now I screwed it up. Okay, so you might notice when I'm, see where my mouse is in the lower part here, I'm trying to open up LyX. And you can see something's going like to a new screen that's off to the left, because that's the way it was set up in my office. And for some reason, my computer's having troubles recognizing that. No, I don't have another screen. I have to close it out, and hopefully when I reopen it, this all works out. Unfortunately, I got to reopen up everything again. Okay, finally. Or, well, I don't mean finally just because you walked in. I mean, finally, I'm able to open up my document here. So you haven't missed much. Anyway, the whole thing is, how can you reuse a chunk? Simply, in your chunk itself, reference the previous chunk. That's it. Like I said, I have not really had a use for it, but you can do it. Okay? Now, also, there may be times where you would like to use some R code that's maybe in a separate file. Maybe you have a lot of R code that's used to generate something. You don't want all the R code to be in your LyX document, though. And so what you've done is created an external program, and essentially you would like to read in the code that's in the external program into your LyX document and basically execute everything like you would normally. You can do that. So here's a very simple R program that I have here where I just put some various aspects of R code. So for example, 1 plus 1. And then I do some, if you probably have heard in another class something called least significant differences for doing pairwise comparisons of means. And so the way that I can do that is with a function called pairwise.t.test, and this is going to allow me to compare the means sugar content by shelf for pairwise comparisons. And also I do the exact same thing with the same function later on, but using the Bonferroni multiple comparison procedure that controls the family-wise confidence level. Okay, now a key aspect to this program here is this line in this line. Basically, what this will tell LyX when it's using knitr is where chunks are located. Now, you might be thinking, why aren't we just using the same syntax that we have been using previously? Well, for some reason, you can't. And so the double pound sign and then at knitr tells LyX, hey, this is where the LSD chunk is. Here's where the Bonferroni chunk is. So in my actual LyX document, then I could combine this into one chunk. I just decided 2 chunks here. So I have create a chunk called read chunk, and then I say read underscore chunk. Where's my file? Since the actual R program itself is located in the exact same folder as my LyX file, I don't need to specify the actual full address on my computer, but you could. And so I just read it in. And then in order to access a particular chunk, I use similar syntax to what we just saw. So here, this LSD here is actually going to pick up that LSD chunk and run it. So if we see in the actual PDF, Here's where I'm reading in the code. And here only that LSD chunk is actually executed. Only that. Now, I haven't necessarily been impressed with the actual syntax that's needed to do all this stuff. Notice there's no, in my external R program, there's no indication of where the chunk ends. And so I guess the way that knitr is approaching this is that, okay, I see a new chunk beginning, so that means the previous chunk has to end there. So notice also how 1 plus 1 was not actually executed because it's not in a chunk. Okay. One little comment about how I created this file here. You can say there's kind of a typo in the document. I used a program listings box to show what the code was in my external program before I actually formally read it in with using knitr and stuff like that. So I use a program listings box just like you did with the last assignment, and I left, unfortunately, in this document the old way that one would have done this in LyX in terms of what various settings you would need to set. And so I just, deleted some of that out. Basically, the exact same way that you did in the previous assignment for SAS, that's how you would do a program listings box that nicely shows the R code without it being in a knitr setting. Okay. So next, let's talk about cache. Get my notes out so I make sure I talk about everything that I need to. So cache, in terms of C-A-C-H-E, basically means a temporary storage spot. Now, in this context, where we're using knitr with LyX, every time that you compile the LyX document, your R code gets executed. So if you have some R code that takes a long time to run, you probably don't want it to always re-execute itself if you haven't made any changes to it. So in those settings, you can use a cache, where basically you run everything like normal, and knitr keeps track now of what you've done in the past, and it puts it into a temporary store spot on your computer. And the only time that knitr will then rerun a chunk, in terms of rerunning an R, the only time that would ever happen is if the chunk has changed. That way, when you recompile your document, everything will run a lot quicker rather than having to rerun every single line of R code over and over and over again whenever you recompile the document. So when you turn the cache on, I'll show you how to do that shortly, a new folder will appear in in the same location as where your LyX file is. And if I click on the cache folder, you can see some stuff that knitr has actually dumped in here. Notice it's called Tukey. The reason being is because my chunk that I'm going to show you shortly is called Tukey. And so this is basically a temporary storage spot that R is keeping, or that knitr is keeping, the corresponding results that were done in R. Okay, so it's not too difficult to do this, but there are some things that you need to be careful about. Simply to turn on the cache, say cache equal true in a chunk. That's it. And so in this particular example here, I'm using Tukey's honest significant differences to do pairwise comparisons. You may or may not have seen this before. Basically, it's just a nice way to control the overall family-wise confidence level, in this particular case at 90%. And just in case you're curious, let's go ahead and take a look at what the results were from Tukey. So in here, I've estimated my model, if you remember using the AOV function, my analysis of variance model. And what we have here then is, and this is the main important thing right here, is p-values that have been adjusted to make sure my overall confidence level is 90%. And it's p-values comparing the differences of means. So for example, this 0.021 is comparing shelf 3's mean sugar content to shelf 2's mean sugar content. The p-value is kind of small, so there is moderate evidence that indeed that there is a significant difference between the two means for the sugar contents. Okay. Now, one thing you do need to be careful about with using a cache is, let's say you have a particular situation where you have a chunk called A and you have a chunk called B. And let's say you only turn on the cache for chunk B. And let's also say that B, the stuff that you do in there, is dependent upon whatever the results were in A. Well, if you change B, well, B is going to be rerun. You don't have to worry about that, even though you have the cache option turned on. If you change B, it will still be rerun. But let's say if you change A, and if the results in B depend upon A, B's not going to be rerun. And it's going to use the previous results that has been obtained. And so now B is going to be incorrect because A had changed. Did I say that right? I hope I did. Any questions? Okay. Now you can tell knitr, hey, B depends upon A. So if A does change, you need to rerun B. And simply the way that you do that is, where's that option? There you go. You include a depends on option. Okay. Now there's another way that you can have knitr to, let's say, try to automatically find these dependencies, and I describe it in the next paragraph. Please take a look at that on your own. I guess I don't have much experience with it, given that the author's concerns about whether or not this experiment, he calls it experimental, given his concerns that if this actually works or not, I have chosen not to actually use it and just manually myself always use depends on when needed. Okay. Now let's next talk about tables. Now obviously tables are an important thing whenever you're creating some kind of, let's say, scientific document, whether it's a homework assignment or if it's a paper, you're often going to have tables of information in there. Let's talk about how we can do this with knitr. Now originally, in earlier versions of knitr, the author of it was like, R already has some nice tools about creating LaTeX based tables directly from R code, so it should be easy to do it with knitr. Later he found out that people didn't necessarily think it was easy, so he made some modifications to his package to make it easier. And so what I'm going to do is talk about his new way of doing some of this stuff, and also the previous ways to do some of this stuff. I still prefer the previous ways because I don't think his function is maybe as good as it should be. Okay. Now, I have a number of examples here. Now, the easiest way to create a table of information using LyX and knitr would be simply to print a data frame. That's it. And that's what I have here in Table 1. So basically what I have here is you'll see my code shortly, where I have by shelf, I have the mean and standard deviation for the sugar content. And I just simply, whatever my data frame name was, I just basically just said, okay, go print it. That's it. And I excluded the code because I was just wanting the table itself. Okay. So let me go over here. So how did I do that? So I have this chunk. First of all, I inserted a floating table. So again, insert float table. And then Here, LyX will automatically call this table 1. You have to actually type in the caption. I put a label here so that I can reference it in my notes right here. And then I just do my normal chunk code, call it table 1, echo equal false. I don't want to see the code itself. I just want the table of information printed. I don't want any of those leading pound signs that you would have by default. And also I want to make sure the background is white, as you would normally expect for a regular old table. And so using similar code to what I did before in the previous class, I use the aggregate function to find the mean by shelf. I use the aggregate function again to find the standard deviation by shelf. This time, though, I put the results into separate objects. And then I combine then the results using the data.frame function, where I bring out my shelf, I round my mean sugar content, and I know this is, I guess it's there. And then also I round my standard deviation of the sugar content, put that into a nice object called save.table, for the lack of a better name. And to print save.table, I could just simply say save.table. Okay? Now, in case I haven't said this before, because I don't think I have, this would result in exactly the same thing. R just makes it a little bit simpler. You're thinking that, okay, whenever you just put an object name there and you execute that object, that means you want to print it. But in this particular setting, I am going to use print. And the reason is because I want to include a particular argument. Row.names equal false. So you may remember that whenever you print an object like a data frame, by default you will have 1, 2, 3, 4, always printed on the far left side. Those are called the row names. You always will have that printed. Well, to make this table look nice, I say just turn it off. I don't want to see it. And so that's how we got the output that looks like that. Okay. Maybe in some contexts, like if you're doing homework, this might be sufficient. But in other contexts where you are actually doing something formal, like writing a paper for a journal, this wouldn't be sufficient, and you would want to do something else. This table 2 is one thing that one could do. This basically is using an image as a table. I think after going through my lecture notes this morning, I was like, that's probably not important, so I'm going to skip over it. You're not responsible for doing it that way. But what you are responsible for is then table 3 here. And so I have this other table here. It's displaying the same information, but it's displaying it in a more formal table format. As a side note, in terms of statistics journals, this is usually the format that you will find for tables. Now, one of the interesting things about this, at least I find interesting, is that notice there's no vertical lines. For some reason, and I don't know, maybe I'm just missing something, for formal tables that are done in statistics journals, usually you don't see any kind of vertical lines to help separate things, and a minimum number of horizontal lines, as you see there. So you don't see, we see here, where basically you have lines everywhere. You don't see that. So, how did I get this table here? Well, there are a few packages in R, excuse me, that will write LaTeX code for you in the context of creating tables. And so I use a package called LyX Table to do this. And to show you how to do it, I'm not going to first look at this in LyX. Rather, I'm going to first show you how this comes about using R directly. And so I have that object, save.table, already available to me in R. And I want to basically have now R print the corresponding LaTeX code that one could use if I was just using LaTeX directly. And I'll show you how then we could use it with LyX. And so to do that, I use the package called LyX Table, which you would need to download and install. Say library LyX Table to tell R, hey, I want to use it. And then there's a function, happens to also be called LyX Table as well, where you put in your data frame. If you want a caption, you include that as well. If you want a reference label as well, you include that too. And so if I just execute that segment of code itself, look what happens. R gives me the LaTeX code to do the table. So I can copy and paste that into a regular LaTeX document, and I would have my table. Notice how it uses the table environment. And it ends with table. Okay. Now you can also do some other little fancier things here by using the print function, which comes in XTable. Print actually is a generic function. So there's actually a function, I believe it's called print.xtable, that's actually executed in this particular case. And in this version of the print function then, for this method function, I have some other options too that I included. Note that I can't get even though I have floating equal true there, it doesn't actually end up working in my LyX document for some reason. I'll show you how to do a floating table another way shortly. And so now I have this, just about the same LaTeX code printed off with some very minor modifications. Now let's go into LyX. Okay. So this will be table 3. So here's my chunk, table 3, echo equal false, because I don't want to see the R code here. I only want to see the resulting output. So that when you look at the document, you don't see the effect. Yes, the R code is right in there when you look at the PDF. And a key new option that you need to include is results equal as is. This tells LyX that what's coming out of this output is actually LaTeX code. Treat it as normal LaTeX code that you would normally have in a LyX document, in this ERT, this LaTeX code box. Treat it as is. Don't treat it as regular, as R code and output. Then I have essentially the same code as before. Library X table, and then I do my print. Okay. Then lastly here, excuse me. So notice this created table 3. I didn't include an actual LyX box that said, hey, this is a table. This did everything like I did everything through LaTeX code. Next, let's take a look at table 4. This looks just the same. It's actually very similar. But let's take a look at the LyX document. In this particular case, I actually did go under Insert, Float, Table, and I got the usual floating table box. Notice LyX is calling this table 3. Well, wait a second. We just had table 3 before. Well, LyX doesn't have a way of knowing that, oh, that code before is actually going to create table 3. In the end, the PDF will get things right, that this is truly table 4. So you don't have to worry about that. But at least when you're viewing it in LyX itself, it doesn't get the table number correctly. Then I do my caption like normal. I do my my label here like normal. And then here's my LaTeX code with the chunk. I'm not sure why I did this, but I decided to actually use LaTeX code to center the table. You don't have to. And then my chunk, table 4, results equal as is, echo equal false. And then I basically just simply put in my a shorter version of my print and XTable functions that I did before. Now, lastly, the way that she revised the knitr package, he included a new function called cable. I guess K for knitr, even though the K is silent, and then able for the table. Why didn't you call it KTable? I don't know. But anyway, that's this function, and that's what actually ends up producing the very last table. Oops. The very last table that you see in the document. Okay? So tables are important. And the trick is basically you're using a function that automatically creates the LaTeX code for you. And you need to tell LyX, hey, this is LaTeX code. Any questions? Okay, let's move on. I briefly mentioned this before, that if you have errors in how you're using knitr, unfortunately, you don't get much, or you don't get good feedback about how to fix the error. And often what I have to do, or at least the way that the approach that I do, is I'll do one chunk at a time, compile the document, make sure it works. Rather than, because then I know, oh, now if it doesn't work, I know where the error is. Rather than, let's say, creating a document, I have 10 chunks in it and I haven't compiled it yet, and then when I compile it, it doesn't work. And it's not always clear where the error is. So I usually do it one block or one chunk at a time. Now, how do you know that there is a problem? You know, sometimes, or oftentimes, you will actually have the PDF produced, and you might be thinking, oh, yeah, great. Hey, everything worked. But then when you look at the PDF, it's like, oh, maybe it didn't. A great way of determining that is that when you have a chunk code in a compiled document, in terms of your PDF, and that chunk code actually is not in the nice courier-like font. It's actually the same font as your normal text. And that should tell you, uh-oh, I have a problem. Another way of knowing that you have a problem is that when you get one of these one of these windows that pop up. In this case, you won't even get a PDF. And we've kind of, I think, maybe mentioned this a little bit before. You know, the way that knitr works, it actually uses the rscript.exe program to run R. And so whenever you see one of these error messages, it means something was not set correctly to our script. All this extra stuff here are just extra options about how knitr uses the R script program. And so when you see something like this, you get a problem. And again, the way that I approach to try to fix the problem is, hopefully, I've been putting stuff in one chunk at a time, and I know, okay, it has to be that in this particular chunk. And what I'll do is I'll, remove some R code, or I'll comment over it to see if I can get it to work. And then just kind of, do very basic steps of decoding, or basic steps of looking for coding errors. Note that if you have a problem with the actual R code itself, let's say that you're trying to, do 1 plus the character A, or that's in quotes. Well, if you haven't, you can't add just simply A in quotes to something. Well, that's going to produce an error. And you'll see the error message in your PDF. And everything else will continue to be run or compiled, so you still get a PDF. Okay, so lastly, some additional notes in here. Interestingly, note that we never ever have to say library package equal knitr. Never have to do that anywhere. There's a function called all_labels, and I don't know if this would be useful or not, but it would actually show you all your chunks, all the names of the chunks. I don't know, I guess it's just kind of a nice thing to be able to keep a record of that at times. There's some other additional notes in here I want you to look at on your own. I'm just going to point out a few of these here. As I've mentioned before, please see my R lecture notes for this course, because in terms of the LyX documents, because that will give you some great examples of using knitr. I purposely did my lecture notes like this to provide you with lots and lots of examples. And in particular, you'll see some examples of how to format text maybe a little bit better at times, and also various options that maybe we didn't really get to in our class. Especially when you are now using knitr for the first, beginning to use knitr, beginning to use LyX. I remember a problem that I often had was I would install a package in R. And then when I go over to LyX, and then also I would have my R program, and I verify that all my R code ran perfectly with this additional package. And then I would copy and paste some of that R code over into chunks in LyX. And then when I compile the document, it would say, oh, you have not installed this package, when I know that I already had installed the package. And what I soon found out was my problem was that I had a number of different versions of R on my computer. And this will occur the more that you use R, because new versions come out about every 6 months, and you might want to download the new version. And what you'll find out is LyX might be still referencing the older version of R than maybe the newest one that you're using normally with like RStudio or with, as I do with TIN. And so because of that, you need to make sure that you understand, well, what version of R is LyX going to use with knitr? And this goes back to then something I showed you before, where if I go under Tools, Preferences, Paths, this path prefix, if you see where my mouse is, tells LyX where it can find various executable programs that it can use with LyX. And at the very end here, you can see that I'm using R 3.2.2. Now, another way to find the same information that I sometimes use too is I can use the function R called r.version. And so if we look at the corresponding PDF then, we have information about the actual version then that LyX is using when it's using knitr. And the key thing is here is that under major and under minor, 3.2.2. That's how I know what version of R I'm using. So now that I know that, and if I have these problems that I described before with installing packages, I know, okay, I'm going to go to R 3.2.2 my computer and install the package in there. And lastly, if you want to see all the options that you can use with a chunk, there's a nice little function that provides that information. Are there any questions? Yeah.
You can't just keep adding different R versions in your paths, can you?
Well, that's a good question. I've never tried that. I don't know what LyX would do. If it would go to the last one, would it go to the first one? I don't know. It would be an interesting experiment. In the end, it's probably not worthwhile, right? But it would be interesting to see how it would behave. Hopefully, it would go to the most recent one. But then again, if you think in terms of the computer, how is the computer going to know that 3.3 is the newer version versus 3.2? Well, I mean, it's just a name to a computer. Any other questions? Okay, so I'm going to go back into my knitr lecture notes here. There's a few things I want to finish up on here. Okay. Can you use knitr with Beamer? Again, we were using Beamer before to help construct presentations. And the answer is yes. I have provided 2 examples on my website that you can download and investigate on your own. In particular, this was all open before until I had to close everything out. So if you remember the very first Beamer constructed presentation that we had, the Hello World thing, if you remember at the end of it, I had an example that shows some R code and output. Now, when we talked about Beamer in class previously, I did a program listings box. Now what I did here is basically took that R code and output and use knitr with it. So you can see how I set my options. And then one of the key things that you need to do, just like with a program listings box, you remember, you had to use a fragile frame. You have to use a fragile frame here whenever we're using knitr. And so let's actually take a look at the presentation. And so reading in the data file, this is what it looks like. One of the things I have found with using Beamer with knitr is that you have to be very conscientious of space in terms of font sizes for the code and the output. Usually I have to use a smaller font size. And also, I might not, if you see where my mouse is here, sometimes there might be, let's say, too much space between the normal text and where the actual code and output starts. So you can see examples of how I handle that then to take care of that extra spacing that might be there. I use some actual LaTeX code where I say /set length /fbox_sep frame box separator -2 millimeters. So I'm going up. I'm removing the space by 2 millimeters. There's other ways you could do this without using LaTeX code, but I so often, whenever I use Beamer and knitr together, I so often always have that. Simply, I put it into my ERT here, my evil red text box, and I just copy and paste it over and over and over again. I find it more simple to do it that way. Also notice here, size equals script size. Again, I wish they would just use a simple font, like a 14-point font as the way to control the size of a font. Instead, there's names. And so I often use script size to make things a little bit smaller than the default. Now also, what I've included, so that's one example. The second example is in 2015 at the joint statistical meetings, I gave a 6.5-hour, 7-hour long short course on the analysis of categorical data with R, based upon my textbook that I wrote. And so my co-author and I, we did this. We did 200 plus frames for this short course, and everything was done using LyX, Beamer, and knitr. So obviously, as you might expect, that will give you some good examples. And so what I've done was I basically put all the LyX code, the LyX stuff for like the first hour of the presentation. I made that available on my website. So you can see one good thing that I is also how you can make separate columns, where you have 2 columns of information as well, as you see there. That's not necessarily with knitr, but that's with Beamer. And so there, for example, is some stuff with my R code and output with using knitr. Any questions? Page 6 then. Okay. Have any of you heard of a language called Markdown? Okay. Markdown is an actual language that's very similar to like HTML, or at least that's what I kind of think of it as. And it allows you to create HTML documents with it. And I first started seeing this in about 2012, I think it was. Some people combine the ability of using Markdown with R and knitr to offer an alternative, you could say, to using LaTeX or LyX with R and knitr. Their stated advantages are that the language is simpler. It is an actual language, so it would be like using LaTeX. It wouldn't be like using LyX. But the language, to some respect, is simpler. The first time I actually ever tried using it was in 2013, and at the time I was like, oh, okay, that's kind of interesting, but it's not very useful. It was too basic at the time. But Markdown, our Markdown, that's what's called together, has improved. And it might become a competitor to using LyX with knitr. For example, I do see some courses in departments of statistics where professors will require students to use R Markdown for all their homework, for example. One thing that has led to some people using R Markdown is the fact that RStudio has been a big proponent of it and has included ways to use it in its graphical user interface. So to give you a quick example, and I am by no means an expert in it, I still, like I said, I think it's inferior to what I've been showing you in class. Like I wouldn't type a journal article, for example, ever using Markdown. But to give you an example, what I did was the first maybe section or so of that serial LyX file that we've been going through, I basically now put it into a Markdown environment here. So if you notice here at the very beginning, you have a # serial data. I'm in RStudio here. I have # serial data example. That # doesn't mean it's a comment. Rather, it means this is the title of the document. Then you see 2 $. Okay, that means I'm in section 1, or I'm in a section. Okay? You have ways to do comments. You can just type regular text. And then the key is, here is a chunk. So if you remember at the very beginning of my serial document where I read in the data, so to read in the data using R Markdown, I use what looks like an apostrophe. It's the I forgot to look at that up this in class. So it's not it's not like a single quotation mark like this. Rather, in the upper left-hand corner of your keyboard, in the same key that has a tilde in it, and you have a little icon below it. Sometimes you might use it like as a prime, for example. That's what's actually being used there, and it's weird syntax. Do that, and it's actually not showing up very well right here. It's showing up a little bit better right there. But this is, so you get 3 of those, I'll say primes, and then a left curly bracket, the name of the, then you have to say R. Yeah, I'm using R. And then you have the name of the chunk. And then you can put in your chunk code like normal, or your R code like normal, and then you end the chunk with those 3 primes. That's how you do it. Anyway, I'm not going to ask you a question about that on a test or anything, but I just want to make sure you're aware of this because this is becoming more popular. Let's see, and I do give you the corresponding file that I did on my website. And so also I'll mention here, notice that up here it says knit HTML. Remember the author of the knitr package, she actually works for RStudio. Okay? So if I click on this, this will actually create an HTML file rather than a PDF, and this is what it will look like. Now, with some of the advances of using R Markdown, they have now been able to set it up so it's not too difficult to create a Word document directly from this, or a PDF document directly from this too. Okay, and then lastly on page 7, I'm sure all of you are wondering, oh, can I do this stuff in do this with SAS? Is there like a knitr equivalent with SAS? Kind of. There is. There is a package that's available from the tech website, LaTeX website, CTAN, called StatRep. That's written by 1 or 2 people at the SAS Institute, the company that owns SAS. And this package, combined with LaTeX, can do some very similar things to what we've just done with knitr and LaTeX and LyX. It's still, with LaTeX itself, is a little clunky. It's not as user-friendly as I think it should be. Last spring, when I first found out about this, because I was curious, was there something similar? Last spring, I found this out, and so I played around with it for a considerable amount of time. I even corresponded with multiple times with one of the authors of this package, and he was very helpful trying to get it to work with LyX. He wasn't aware of that LyX existed. And we got something to work, but I don't feel as though it's as good as it should be, so that's why I didn't present it in class. But I at least want to tell you that there is something out there that can kind of do some of the same stuff as we have been doing with LyX and R. Now, also, there's a number of ways in SAS already where you can have SAS automatically generate LaTeX code for you. Similar to how we were using the KTable package in R, there are equivalencies in SAS. And I give you some information about that. This Carl Schwartz reference is a good one, if you're interested. Okay, so that ends the knitr stuff. And also I do want to say, if you do want to learn more about R Markdown, and I don't have this in the notes, you go to rmarkdown.rstudio.com. This is an RStudio website that contains lots and lots of examples of doing this stuff. Okay. Are there any questions? Yes.
So when you use the Markdown with RStudio, do we have to change the environment, or is it just the RStudio?
Well, it will recognize based upon the file extension that you're using R Markdown. I think it's a .rmd file. Yes, a .rmd file, which I mentioned on page 7, and you can download that from my website. So it will recognize that. Let's say if you wanted to do a completely new file, notice if I click on New here, R Markdown. So that's how it goes. Now, obviously, it needs to know that. Otherwise, it doesn't know, well, are you doing R code or what? Any other questions? Okay. That's it for today. Have a good break. We will next meet in 1 week.